Okay, so after you see the linear system like this, the first thing that you got to do is to start writing the equation down in the term of operator d. Okay, so then our first equation, we would get what? 3d squared x, right? This one is 3d squared x. This one, d squared y plus 3dx plus 2dy plus 2x plus 3y equal to exponential of t. And then any term that have x, you put them together. So you would get 3d squared plus 3d plus 2, the whole thing times x. And then any term that has y, you also put them together, so you would get d squared plus 2d plus 3y. That is our first equation. And then for our second equation, we are going to do the same, writing it down the term of operator d. So we got 2d squared x plus d squared y minus dx plus dy minus 2x plus y equal to 8. Again, any term that have x, put them together. So you got 2d squared minus d minus 2x plus d squared plus d plus 1y equal to 8. Now you have two equations. The next step that we are going to do is to write down in the term of matrix, in the form of matrix. So you would get like this. And then again, find s by using Cramer rule. Now you know how to find determinants, right? Don't forget to put a function behind the operator sign. See, when I times it, I always put the term of function or constant behind the operator sign. Just find the determinant, okay? The bottom one, we get, I do the bottom, but you got to try to time each term yourself, okay? I would put the final form for you. And the top one, you would get d squared times et. It means second derivative of exponential of t equal to exponential of t. the first derivative of t, the first derivative of exponential of t equal to exponential of t plus exponential of t. The second derivative of 8, 0. The first derivative of 8, 0 again, and then minus 24. So we would get it is a non-homogeneous differential equation, right? Okay. Now our xc we find from characteristic equation, which is m to the power 4. How many values, how many roots of m that we should find? 4. Okay. The first one is m plus 1. The second one is m plus 2. And the other two is plus minus 2i. So m is equal to minus 1, minus 2, and plus minus 2i. That's our 4 roots of m. So our xc is equal to c1 plus c2 plus c3, c4, now find xp. xp I'm going to use the shortcut method. A is equal to 1. You just put 1 into each d. What you get? 1, 3, 4, 6, 10, 10, 20, 30. 3 over 30 minus, now this term a is equal to 0. So you put 0 to the d term, so we would get 24 divided by 8. That is our xp. So at the end, x is equal to xc plus xp, which is equal to this term. And then we do the same with the y term. So started with the Kramer root y. we know that if you take a look at the determinants of the denominator of y, so it's exactly the same as the denominator of x, right? So if you're sure that your x is right, just copy it for y. So we would get a to the power 4 plus 3d to the power 3 plus 6d squared plus 12d plus 8. And on the top we got 3d squared plus 3d plus 2 times 8 minus 2d squared minus d minus 2 times exponential of p. Okay. On the top we do 8 in there. D squared of 8 is 0. D8 is 0. So the first term we have only one left, which is 16. Second derivative of exponential of t, right? So you would get minus 2 times exponential of t. First derivative of exponential of t, and then minus minus equal to plus, and then the last term 2 times exponential of t, minus minus equal to plus. Right? Minus 2 plus 2. Okay, then we got just exponential of t. Again, y is equal to yc plus yp. You know xc. The terms is exactly the same. So now you know that your yc is just equal to xc, which is c1 times right? Because it's exactly the same function. Now we are going to find yp. Yp, we are using this one. I take 16 out. And times exponential of 0t. This one, a is equal to 0. You put 0 there in each term of t, so you would get 8. 16 divided by 8 is equal to 2. This one, our a is equal to 1. You put 1 into all these terms, so we got 30, so we got 1 over 30 exponential of t. So now our y is equal to yc plus yp, which is equal